Okay, hello everyone. We are going to be discussing about indices. So we are going to be looking at some laws of indices here. Laws of indices. The first one is multiplication law. You can see that we have what is called the base and the index. The base and the index. Once they have the same base and they are multiplying, pick one of the base and add the powers there. You can see that we added a plus b there. So we have examples on simple application of this law. The simple application, we have 3 raised to the power of 5 times 3 raised to the power of 2. Once they are the same base, pick one of the base, add the powers there. 5 plus 2, which is 7. Then we have the second one, 7 raised to the power of 2 times 7 raised to the power of 3. They have the same base, 7, and they are multiplying. So 2 plus 3 is 5. That is the first law. The second law is when they are dividing. When they are dividing, you subtract a minus b, or it can look like this form, but you still subtract. We have examples on simple application. 2 raised to the power of 4 divided by 2 raised to the power of 3. That is 4 minus 3 is 1. 3 raised to the power of 4 over 3 raised to the power of 2. That is 3 raised to the power of 4 minus 2. That is pick the base and subtract the powers. The third law is anything raised to the power of 0 is 1. From here you can see that we have simple application. 2 raised to the power of 0 is 1. 10 raised to the power of 0 is 1. Then the next one we have the negative index law. When we have x raised to the power of minus a, once you want to remove the negative power or index or exponent, introduce 1 over the negative will go out. If you want to bring it up, it will take minus. And there is something here, in a scenario or in a case where we have numerator and denominator, talking about fraction. So instead of doing 1 over the fraction, what you will do is that the x down here will go up, the y here will come down, and it will take a positive symbol, a positive power. Can you see that now? So we have an example. 10 raised to the power of minus 2 is equals to 1 over 10 raised to the power of 2. The negative has gone out. Okay, look at this application here. We have 4 over 5. This is a fraction. So 5 will go up, 4 will come down. This minus will change to plus. Then we have the power law. X raised to the power of a times b. You can see we have a power inside and a power outside. So in this scenario, they are going to multiply themselves. A times b is a, b. And we have simple illustration or application here. 2 raised to the power of 3 times 2, can you see, is 6. 5 times 2 is 4. Then we'll go to fractional index. Fractional index. There are 2 of them. When the power, the numerator is 1, it's talking about roots over a. So a over a root, square root of whatever that is here. Like we have 16 raised to the power of 1 over 2, square root of 16. Once it's more than 2, you put the number here. Like we have 27 raised to the power of 1 over 3, which is cube root of 27. If this thing was like this, let's say 16 raised to the power of 1 over 4 is equals to fourth root of 16. And that is how to go about that. So this law 6, there's an extension there. Let me try to write it here. The extension of that law 6 is when the power is no longer 1 but another number. Let's say we have, this is the 7th law. We have, this is x raised to the power of b over a is equal to bracket a root x all raised to the power of b. So these are the application. For example, we have 4 raised to the power of 3 over 2. So once it's 2 is square root, that is square root of 4, all in bracket 3. All in bracket 3. All in bracket 3. X raised to the power of that is square root of 4 raised to the power of 3. Let's go to the second scenario where we have something like, let's say 125 raised to the power of 2 over 3 is equal to, this is 3, that is cube root of 125 all raised to the power of 2. And that is how to go about this question here. So I just explained the basic law. So in our next video, we are going to be looking at how to apply all the 7 laws, either 1 or 2 or more of them in solving let's say in solving questions in indices. We are still coming to indica equations. Thank you.